Okay, part of today's plan is to just go through my notes that are on Blackboard called Diffusion and Osmosis. And I don't think you need me to read them to you, especially because you've had some exposure to them with the videos from yesterday. You learned about three types of passive transport. First was the simple diffusion, second was facilitated diffusion, and then there was a third, which was osmosis. And osmosis is just the diffusion of water. So diffusion is the movement of any substance, remember, from high to low concentration. So what governs transport, what determines the direction of movement is concentration. And we say the concentration difference is called a gradient. The steeper the gradient, just like if you're driving down a hill, the bigger the concentration difference. So if we're talking about sides of a cell membrane, maybe on one side the concentration of salt is 5, on the other side the concentration is like 35. That's a really big concentration gradient compared to, say, 5 on one side and 7 on the other side. So we're still going to have some movement with the 7 and the 5, but it's just not going to be that dramatic. So I use this little analogy that's like a slide at the playground, showing that when you go up a slide, whenever you go down the slide, when you're going from high to low concentration, it requires no energy. Okay, what determines the movement is the fact that this membrane is selectively permeable. So that's where you learned yesterday about polar and nonpolar molecules. Okay, you're going to see me writing concentration like a percentage sign. So that's why I wanted to kind of add a few things to my notes. Okay, so moving along here, you can kind of read this on your own. Factors that affect diffusion. You remember there's two parts of a solution. There's the solute, which is the substance being dissolved, and the solvent. That's really important. And in this case, because we're going to be talking about the movement of water or osmosis, water will be the solvent. Okay. Concentration difference, I already talked about that. So with passive transport, which includes both simple diffusion and facilitated diffusion, substances move from high to low concentration, no energy. That substance could be a solute. That substance could be a solvent. Okay. Next week, we'll talk about active transport. That requires energy. One of the reasons is because it may be going against the concentration gradient, which is when it goes from low to high. So just like if you'd ride up or try to walk up a slide at the playground, that's going to take energy as opposed to going down the slide. Okay. Sort of the end result of diffusion of a substance, a solute or water, is that both sides of the membrane have relatively the same concentration of the substance. But the thing is like once it does reach an equilibrium point, where it's the same on both sides, that doesn't mean molecules just instantly stop moving. You're still going to have some movement across the membrane. It's just going to be small and there's no huge net movement. Okay, dynamic means that it's still changing. Equilibrium means that they're the same. Okay. You can read all this and you can copy this down, and I definitely would, but I feel like students in the past have always struggled with this, so I don't want to just say, here you go, copy it, good luck. I wanted to take a few minutes to just talk about it with you guys. So when we describe a solution, we are describing the solute concentration. So like the prefix hyper, just like hyperactive, hyperglycemia, if you've got high blood sugar, hypertension, if you've got high blood pressure. There are probably other hypers that I can't think of right now, but hyper just means high. So that means a lot. So in a hypertonic solution, notice all my dots that I've drawn there. That means it's really concentrated. That's like drinking salt water from the ocean. On the opposite end, there's hypotonic. So again, hypothermia or hypoglycemia or hypotension or hypoactive thyroid, let's say. That means it's low, it's underreactive, it's underproductive. So that means there's not a lot of solute. And it's always kind of in reference to the opposite side of the membrane. So when we say a solution is hypertonic to a cell, that means that there's a lot more solute in the solution compared to inside the cell. So it's always relative. If it's hypotonic, that means there's actually more solute inside the cell then outside. So that would be something, if you're going to drink salt water, that's the kind of salt water you'd want to drink. And then finally, there's isotonic. Iso, like isosceles triangle, or isometrics means the same. And again, it's not perfect, because molecules are always moving, but that means that the solute concentration is the same on both sides of the membrane. So you wouldn't expect to see like a big movement in one direction. So now let's have a look at what happens to the solute in a hypertonic solution, if I asked you. So remember that any substance moves from high to low. So in a hypertonic solution, there's a lot more solute in the solution than in the cell. So the solute's going to move in from high to low. Okay, in hypotonic, there's a lot more solutes inside, so it's going to move out. And in the final situation here, the isotonic, we're going to draw this sort of double-sided arrow showing that it goes like in both directions. Now on the flip side, it's kind of an opposite thing. What happens with osmosis? Now osmosis is the diffusion of water. If we have a lot of concentration of salt, that or whatever it is, that solute, that means there's less water in terms of concentration. Inside, there's actually more water, less solute. So it's just the opposite. Like here, it's high solute, low water. Inside, it's low solute, high water. So take a minute to think about that. So if it's higher water inside compared to outside, water is going to move out. Now, if water moves out of the cell will change in terms of size. So you know that probably happened to you before. If you've taken a big gulp of seawater, or maybe you've eaten a lot of salty foods, you get dehydrated, right? Because your cells lose water. Down here, we have more pure water outside, so the water is going to want to move in. And if water moves in, the cell is going to get bigger. It's going to swell. It probably won't burst, but you never know. Okay. And then the last situation, same thing. Same, if solute's the same on both sides, water's the same. So we would say that they would both have this sort of double-sided area. So if I don't show you this by dots, I'm going to show you this by percentages. Okay. So consider this. Inside the cell, the solute is 35. Outside the cell, the solute is 80. 80 is much higher than 35, so we would describe this solution as hypertonic to the cell. Okay? So that's how you name the solution. You look at the solute concentration relative to the cell. So 80 is higher than the cell's 35, so the solution is more concentrated with solute, so it's hypertonic. Now on the flip side, water is higher inside, 65, than outside, which is 20. So therefore, water will move from high to low. So water will move out. Okay, so in a hypertonic solution, water will move out of the cell. Okay, and I didn't ask you about what happens to the solute, because usually we don't talk about solute movement when we talk about osmosis. We just talk about water movement, right? Because osmosis is just water. But I could ask you the solute too, because that would be just diffusion. One thing also to notice that any given solution should equal 100%. So look at this concentration of the solution here, 80 plus 20, 35 plus 65. Okay, the 35 and 80 don't have to equal 100, just like the 65 and 20 don't have to equal 100, but together these have to equal 100, and these have to equal 100. Okay, so here's an example of hypotonic. So if I have 20% solute in the solution, 40% in this cell, you see how 20 is less than 40, so that would make that a hypotonic solution. Okay? If we're talking about which way will water move, water is 80 out here and 60 in here, so water will move in. All right, that's it for my notes. Your assignment is this. This is on Blackboard. So this is a Google Doc. You can just edit this and share with me. I'm about 15 seconds from my free recording limit. So hopefully this makes sense and this helped you guys. If you have any questions, I hope to be back next week at some point, and have a great weekend, and I'll see you soon, hopefully. Okay, bye.